So what you are looking at here is the beam as it leaves the spatial filter, and it is not a particularly ideal output given the uneven brightness. So if you were to try to use this to generate holograms, it would have a negative impact on the quality of those holograms. Now, as it turned out, the diameter of the beam going into the spatial filter was too large. So using an iris, I was able to stop down the size of the beam, and as I did so, I noticed quite an improvement in the output of the spatial filter. And so you can see that here with the beam exiting the spatial filter, it now has a clean Gaussian profile. The problem with using an iris is that it wastes a lot of light. So instead, it would be better to use lenses to reduce the size of the beam diameter, and there are a couple of ways to achieve this. One method is to use a Keplerian telescope, which consists of two convex lenses spaced apart by the sum of their focal lengths. So to demonstrate this method of reducing the beam, I have two lenses. Here is a 25mm lens, and you can see that it has quite a bit of curvature. With such a short focal length, it will rapidly bring the light to a focus, and then after the focus point, it will quickly diverge. And here you can see that same lens mounted into a holder for placement onto the optical table. By comparison, here is a 100mm lens. It has noticeably less curvature, and this will serve as the input lens into the Keplerian telescope. And when one divides its focal length by the 25mm lens, it should be possible to reduce the beam diameter by a factor of 4. Now this assumes that the lenses are spaced apart again by the sum of their focal lengths, which should be 125mm or about 5 inches. Here you can see that with just the 100mm lens, the beam diameter is reduced substantially at the focus point, and then it quickly expands thereafter. Now let's bring in the 25mm lens and position it so that it is 25mm in front of the focus point from the 100mm lens. This gives us the distance of 125mm between the two lenses. So with this arrangement, we can see that the beam diameter expands at a much slower rate compared to the single 100mm lens. So the Keplerian telescope is one method to reduce the beam diameter. Another method is to simply use a single lens that has a long focal length. So here's another convex lens, this time with a focal length of 1000mm, and you can see that the beam diameter first has to reach a focus point, and after that it will start to diverge, but only very slowly. So this is a simple and effective way to achieve a desired beam reduction, as only one lens is needed. So here is what the beam diameter looks like without the lens, and here's what the beam diameter looks like with the lens in place. So the beam reduction is quite noticeable. Now that the beam diameter has been reduced, the output of the spatial filter shows a clean Gaussian profile. Furthermore, using a lens is much better than using an iris, as the lens preserves the laser power level. So that's about it for this video. Thank you for watching, and see you next time.